Okay, these are the notes for 7.5 polynomial connections, but we are going to do things a little bit out of order. So if you'll flip to the back of your notes page, we are going to start with number 3. All right, we're going to start with number 3. So we are asked to find the polynomial in standard form with the roots that we're given. We're given a root of 3, and we're given a root of square root of 2. Now, there's a blank here, which signals to us that something else is going to happen. Okay? And what that is that, that's really thick. Okay, what that is that radical roots always come with their conjugates. Radical roots always come with their conjugates. So we have the square root of 2, so we also have negative square root of 2. Why aren't you getting smaller? Okay, so I'm going to rewrite these as roots. Okay, so I'm going to write these first as roots. So x equals 3, x equals root 2, and x equals negative root 2. Okay, and I'm going to take these roots and I'm going to turn them into factors. All right, so turning them into factors means I'm going to get them set equal to 0. So this is going to be x minus 3 equals 0, x minus root 2 equals 0, and x plus root 2 equals 0. Okay, and now I'm going to multiply my factors together. So I've got x minus 3 times x minus root 2 times x plus root 2. Now these roots, or sorry, these factors, I'm going to multiply so that I can get some of my radicals to cancel out. Okay, so I'm going to keep this x minus 3, and then I'm going to multiply. X times x is x squared plus root 2x minus root 2x. And then what's negative root 2 times positive root 2? 2, but what about that sign? Minus 2. Okay. All right, then we know these cancel. That is not a coincidence. This was a minus b times a plus b, which is always going to give us a squared minus b squared. So this is x minus 3 times x squared minus 2. But we're not done because we want the polynomial in standard form. So we're going to go ahead and keep multiplying that out. So it's going to be x minus 3 times x squared minus 2. Let's go ahead and double distribute that. X cubed minus 2x minus 3x squared plus 6. Is that in standard form? No, why not? Yeah, it's got to go in order of your degree from greatest to least. So x cubed minus 3x squared minus 2x plus 6. Okay? Oh, I can go here. Sorry. I was like, how do I move? Okay. Now let's do part B. All right, we have 3 plus 2, 3 and then 2 plus I. What do you think we're going to have here? Yeah, 2 minus I. Because complex roots also come with their conjugate. Complex roots always come with their conjugate. All right, so same process. Going to write them as roots first. X equals 3. x equals 2 plus I, and x equals 2 minus I. Okay, what do we do now? Good, subtract so we can get them set equal to 0. So this would be x minus 3 equals 0, x minus 2 minus I equals 0, and x minus 2 plus I equals 0. Okay? All right, so now I'm going to multiply x minus 3 times x minus 2 minus I, and x minus 2 plus I. All right, we're going to multiply the second two binomials first so that we can get rid of some of those i's. Okay, so we're going to have x minus 3 times, all right, let's just go step by step. We're going to start by distributing this x. So x squared minus x squared minus 2x plus ix. Now we're distributing this negative 2. So minus 2x plus 4 minus 2I. And then distribute your negative I, so minus ix plus 2I, and then minus I squared. What do you think we should do now? Combine like terms. Can anything cancel? Minus 2I and positive 2I. Plus ix and minus ix. We can combine those, right? What happens to minus I squared? Positive 1, right? Because negative 1 gives me positive 1. All right, so this is going to be x minus 3 times x squared. We had minus 2x and minus 2x, so that's minus 4x. And then we had plus 4 and plus 1, so plus 5. Okay, but are we done? Nope, we got to multiply those out. All right, so go ahead and double distribute those. What do we get when we combine like terms? X cubed minus 7x squared plus 17x minus 15. Okay? Everyone okay with that? Okay? All right. Now let's talk about factoring. All right? When in this unit, factoring completely, we're going to do it a little bit differently. We are going to keep going until you get all first degree polynomial or first degree factors. Great. You got homework. Okay, bye. Study for your quiz for Monday, okay? Thank you. All right, so keep going until you get all first degree factors, meaning no x squareds, no x cubes, okay? We've got to get them all down to x to the first degree. All right, so this is a little tricky, but the way we're going to do this is going to be to use irrational and complex numbers. What's happening? Stop! What are you doing? That was so weird. Okay, so we know how to start factoring x to the fourth minus 81. What do we do? Difference of squares. So x squared minus 9 and x squared plus 9. And we know that x squared minus 9 can become x minus 3 times x plus 3. Okay? Now in the past, we stopped here. And for much of your future, you will stop here. Okay? But there are times where you need to get them all the way down to all of your roots being represented as factors. So this is a fourth degree polynomial, so there will be 4 roots, so we need to come up with 4 factors. Okay? So what I'm going to do is I'm going to think about what roots I could get from this one that I don't know how to factor. So x squared plus 9, I'm going to set that equal to 0. Okay? So x squared equals negative 9. So then x equals plus or minus the square root of negative 9. What is the square root of negative 9? 3i. So plus or minus 3i. So that tells me that 2 of my roots are, or one of my roots is 3i and one of my roots is negative 3i. So now I'm going to take these and I'm going to come back over here and I'm going to try and write my other 2 factors. So I'm going to keep x minus 3 and x plus 3. And then I'm going to use these roots. X minus 3i and x plus 3i. Fourth degree polynomials, so we got down to 4 factors. All right, now we're going to do part B. How do I go about starting part B? Group them. All right, so I can pull out an x squared. Here I can pull out a negative 3. So I get x squared minus 3 times x plus 1. Again, normally we would stop, but for today we're going to keep going. We have a third degree polynomial, so we're going to keep going until we get this down to 3 factors. All right, so take this polynomial, or sorry, this binomial, x squared minus 3, and let's find the roots that we would get from that factor. So we would get x squared minus 3 equals 0, so x squared equals 3. So x equals plus or minus the square root of 3. So that gives me 2 more roots. X equals root 3 and x equals negative root 3. Okay, so like we did in the last one, we're going to take that. We're going to come and we're going to write all 3 factors. So what's one we could write? X plus 1. What's another? X plus the square root of 3 and x minus the square root of 3. Yes, ma'am. Like, why do we get it all the way factored like this? Basically, it's just so much of this unit is coming up with roots and being able to graph and being able to look at those roots and all this stuff. So this is a way for all roots to be represented as a part of a factor. So it's just kind of connecting all of the graphing and stuff that we're doing. Okay? All right. All right, this isn't really C. This is a new problem, so call it number 5. Okay, pretend this graph wasn't there. Okay, pretend it wasn't there. If I just asked you to find all the roots of x to the fourth plus x cubed plus 2x squared plus 4x minus 8, you wouldn't really have any strategies. Okay, we can't factor that. We don't know any tricks for that. Okay, so beyond using our calculator to look at the graph, which is what I've given you here, we don't really have anything we can do. So that's why I've given you the graph. Now the graph helps us identify two potential roots. Okay, but what's the degree of this polynomial? 4. How many roots does a fourth degree polynomial have? 4. We've got to be able to find all 4 roots. So we're going to use the roots that we can see here. We're going to prove that those are roots, and we're going to divide out those factors so that we can keep pushing this down from a fourth degree to a third degree to a quadratic, because we can solve quadratics. We know lots and lots of methods to solve quadratics. Okay? So we're going to keep working our way down to turn this into a quadratic so we can solve it. Yeah. So we are going to be able to use synthetic division to help us out. Yeah. So we're going to divide out linear factors for these roots. Okay? Because basically, if I want to show that x equals 1 is a root, I'm basically going to divide out x minus 1 and make sure it's a factor. Okay? So I can use I can use synthetic division here to check if x equals 1 is a root. And that's what I'm going to do. So I'm going to set up synthetic division. Remember, when you set up synthetic division, you're always checking that every single power is represented. Are all of our powers represented here? Yeah. So 1x to the fourth. Oh, sorry. What am I doing? Silly me. All right. Just 1. And then 1. Oh, man. All right. Then 2. Then 4. Then negative 8. All right. So bring down your 1. You get 1, 2, 2, 4, 4, 8, 8, and I get 0. What does it mean that I get a remainder of 0? Very good. X equals 1 is a root for sure. It also means that when you divide by x x minus 1, this is what you get left over, right? So let's write that out. Let's write out what we would get. So we would get x, let's see, this is my remainder, right? So this is my constant, my x squared, my x cubed. So x cubed plus 2x squared plus 4x plus 8. All right, so we got it down from a fourth degree to a third degree. What should we do now? Yeah, divide by x. It would actually be x plus 2, right? We divide by x plus 2 to show that x equals negative 2 is a root. So let's set up synthetic division for that. Yeah, because we've got to keep getting it down to a quadratic so that we can solve it. So now we're checking the root x equals negative 2. Notice that my coefficients are the same that I got here, right? So I could have just not, sorry, I'm trying to get that to go away. I can't. I could have just not rewritten this. I could have just used those coefficients right there. Okay, and that would have been fine. All right, so I bring down my 1, negative 2, 0, 0, 4. Nope, that's the remainder. That's divided out. So again, I get a remainder of 0. So that tells me that x minus x equals negative 2 is for sure a root. So what I've been able to do is now I've gotten this down to x minus 1, right, for that root, x plus 2 for that root, and then this, x squared plus 4. That's why I went through synthetic division, so that I could divide these out. Yeah? All right, so now I'm going to take this x squared plus 4, because it's a quadratic, and I'm always going to stop once I get a quadratic, because I know how to solve every single quadratic. I can square root, I can factor, but I also know a method that works every single time. What is that method? Quadratic formula. So we can try factoring. If factoring doesn't work, we can square root, but we can also use the quadratic formula. So I've got x squared plus 4 equals 0. So x squared equals negative 4. So x equals plus or minus the square root of negative 4. And what does that give us? Plus or minus 2i. Square root of 4 is 2. Square root of negative 1 is I. So I now know what all my roots are. So I can write out all my roots. 1, negative 2, and plus or minus 2i. A 4th degree polynomial, need 4 roots, and I found them. I would put a big circle or star by this question. You will see a question like this show up on your quiz. When's that quiz, by the way? Thank you. All right, now let's flip to the front. Yes. So you could plug in the roots x equal 1 and x equal negative 2, and you could show that they are roots, but that wouldn't bring you down. It wouldn't keep knocking degrees down so that you could get down. Guys, please stop talking. It wouldn't keep lowering your degree and lowering your degree so you could get down to this x squared plus 4 so that you could find your other roots. Does that make sense? All it would do would show that these are roots, but it wouldn't help you find the missing 2. Okay? All right. Flip to the front and flip to number 2, please. All right, this says how many times is 2 a root of x to the 4th minus 5x cubed plus 6x squared plus 4x minus 8? So what does that imply? Yeah. Yeah, we're going to keep testing x equals 2 as a root to see how many times we can get it to go. Okay, and we're going to use synthetic division to help us here. All right, so I'm going to start with I'm going to start with 2. All right, and let's go ahead and go through our synthetic division. All right, and what do we find out? Yeah, this is in fact a root. So we know it's a root. Now the question kind of implies that it's a root more than once. So we're going to keep going. Now I could rewrite this and then set up synthetic division, but wouldn't these just end up being my top row? Yeah, so I'm just going to set up synthetic division again right here. And what happens? It works again. All right, let's try it again. What happens? It works again. What are we at here? What would this be if I wrote it out as my answer? X plus 1. Is 2 going to be a root of x plus 1? No. So we are done. So what's our answer? Yeah. So what we'll say here is that x equals 2 is a root 3 times. Okay? And that has a nathier way of saying it, if you will. What we say is that x equals 2 has a multiplicity of 3. Okay? A multiplicity of 3. All right, so let's talk about what that means, multiplicity. All right, multiplicity means the number of times a root occurs. The number of times a root occurs. Normally, a root has a multiplicity of 1. Okay? Normally, it has a multiplicity of 1. So what that looks like is at our root, okay, at our root, we're just going to, just like we normally do, go through our graph at that root. So for a multiplicity of 1, we're always going to go across the x-axis. All right? For a multiplicity of 2, you actually know what this looks like, you just don't know you know what this looks like. Yeah, it's going to look like a quadratic, okay? Now, think about it. Back when we learned quadratics, okay, we said the phrase, it either has 0 roots, 1 root, or 2 roots, okay? Okay? But we know now that a quadratic is a second degree polynomial, right? So how many roots does it have to have? 2. Second degree, 2 roots. So really it didn't have 1 root. It had 1 distinct root, but that root had a multiplicity of 2. Okay? So remember what that graph looked like. When we had a graph that we said only had 1 root, it hit our x-axis, then it curved back up. It was like when the vertex was on the x-axis. Okay? It hits and it bounces. It didn't really have 1 root. It had a root with a multiplicity of 2. Okay? So when you have a multiplicity of 2, you're going to bounce off the x-axis. The third one is going to start with a C. So if we have a multiplicity of 3, it's going to look like our y equals x cubed does when it goes through the origin. So it's going to make this curved cubic shape. Sorry, makes it like right there. But it's going to kind of curve through the x-axis, right? It's going to curve through here like a cubic function. So you can use curve or you can use cubic. So A, B, C. Yes. I'm just showing you A, B, C, a way to remember it. That's okay. Nope. Okay, so let's kind of think back on this problem a little bit. We saw that x equals 2 was a factor, or sorry, x equals 2 is a root 3 times. So when I write this out in factored form, I would have x minus 2 times x minus 2 times x minus 2. And then what was our last root? Or sorry, our last factor? X plus 1. So that tells me that my roots are x equals 2 with a multiplicity equal to 3 and x equals negative 1. All right, what's this graph going to do on the right side and what's this graph going to do on the left side so that we can sketch ourselves a little graph? Rise on the right because we have a positive leading coefficient. And it's going to rise on the left because we have an even degree. What's our y-intercept? You might have to go back to the original problem. Negative 8. All right, so we're going to rise on the right. At x equals 2, we have a multiplicity of 3, so you're going to do your best to kind of make it look, oops, do better than that. You're going to do your best to make it look like a cubic, sorry, that's the best that's going to happen, kind of a cubic curve through that root. Hit your y-intercept. And then we're just going to go through or across at x equals negative 1. Okay? Yes? Yep. Yep. I mean, it's hard to count. You're just going to do the best you can. Okay. You're going to try number 1 now. So try number 1. All right, so tell me, what do we know? X equals 2 is a root. What do we say about it? Multiplicity of 2. And we also know that x equals negative 1. What's our y-intercept going to be? Let's see. Remember, for your y-intercept, you have to plug in 0 for x, right? So that's 2 times 0 minus 2 is negative 2. 0 minus 2 is negative 2. And 0 plus 1 is 1. So 2 times negative 2 is negative 4. Negative 4 times negative 2, negative 8. So 0, negative 8. Oops. Yep. You got it. Wait, no. What? So 0, 8. Okay, what's going to happen on the right side? Right, because our leading coefficient when we multiply this all out would be 2. What's going to happen on the left side? Think about it. If we multiply this all out, what's our degree going to be? 3. So this is going to fall because an opposite degree. All right, so let's plot this. So I have a root at x equals 2 that's going to have a multiplicity of 2. I have a y-intercept at 8. And then I have an intercept at -1. I'm going to rise on the right side. Let me switch colors so you can see a little better. I'm going to rise on the right side. When I get to this root, I've got to hit it and then bounce back up, right? Kind of like a quadratic. I know my picture's not great because the pen's acting up, but you know what I'm saying, right? It's going to hit like a quadratic. Okay, then we're going to keep going through our y-intercept. Okay, and then x equals -1 just was a root one time, right? So we're just going to go through, sorry, my pen sucks, through -1. Just go through there. Yeah? What would the domain be? Yeah, all these graphs have domains of all real numbers, right? What would the range be? All real numbers, because you're going all the way up and all the way down. Okay.